So for question 10, we have the f of x is sum of two parts. One part is constant and other part is various as x squared. So we can write f of x is equal to, the first part is constant, so we have k1 plus the second part is directly proportional to x squared, so we have k2 x squared. Then we have the condition of f2 equal to 4. So we have the first formula to become 4 is equal to k1 plus k2 times x squared. We substitute x is equal to 2, so we have 4k2, so that's the first equation. And for the second condition, we have the y value is -1, the k1 plus -3 squared give you 9, so plus 9k2, so that's the second equation. To eliminate k1, we can use 2 minus 1. Then we have -5 is equal to 5k2, which means that k2 equal to -1. Then we can substitute the k2 equal to -1 into the first equation. So we have 4 equal to k1 plus 4 times -1, so that the k1 is equal to 8. Then we can substitute the value of k1 and k2 into our initial formula. So we got the value of f of x is equal to k1, which is 8, plus k2 gives you -1, so 8 minus x squared. So that's our formula of f of x. So now the question A is asking about what's the value of f of 4, f of -4. So which means that we substitute x is equal to -4 into our equation here to get 8 minus -4 squared, which is equal to -8. So that's for question A. But for question B, it's a little bit tricky because we need to do something more. So now we have the value of P and Q and R. Those are the points lying on the y is equal to f of x. And someone is claiming that there are 4 different positions of R such that the triangle PQR is going to be equal to 64. So do you agree with this? So first of all, we can just draw the xy coordinate. We can draw a Cartesian coordinate here. So we have the p is equal to -4, and we don't know the y value because this p is actually on the curve of f of x. So basically, we just substitute this -4 into the x, then to find out the value of p. So we have just done this, it's actually -8. So we have this is the p value should be -4, -8. And similar for q, we can substitute the 4 to becomes here. Then 8 minus 4 squared gives you -8 as well. So that we have the q value is 4, the y value is also -8. So basically means that the p and q actually are on the horizontal line. So we can just put it here. We have the p is, this is -4, and this is 4. We have our p value here, -4, -8. And we have a q value here. We have 4 together with -8. So they're actually on a horizontal line. So as we don't know where is R can be a random point here because the curve is going to be looks like this, isn't it? So that's the curve of the 8 minus x squared. The x coordinates, the y coordinates here is going to be 8, and we have the value x here. But actually, we don't know where is our where is going to be our r. So if you don't know something, you can just set a variable to it. So for question B, as we don't know what is the value of r, so we can let the x coordinates becomes r, and the y value is going to be f of r. But actually, the f of r is equal to 8 minus r squared, isn't it? So let's say the r is somewhere around, let's say the r is here. You can say the r is here, and in general, the coordinates is going to be r together with 8 minus r squared, isn't it? So now if you want to find out the area of the triangle PQR, what's that mean? First of all, you need to have the base together with the height. So for the base is actually equal to, using the x value minus them together to get 4 minus the -4. This one you can get 8. So the height is actually the perpendicular distance from point R to this line PQ. So the line PQ is the y coordinates will give you -8, so that the height, you can use the formulas, which is the 8, the y value, the y2 minus y1, and then take the square and then square root it. So 8 minus r squared, and then we can minus the -8, which is the y value of this horizontal line, and we square all of them, and then we take a square root. So if we simplify it, we can get 8 minus 8, which give you 16, isn't it? So we have 16 minus r squared, then we squared it, and then we're taking the square roots. We can expand the brackets, then we can say we have r to the power 4 minus 32r squared plus 256. And remember the square root. So after that, as the area of triangle is equal to half times the base times the height. So we can say that the 64, we have the question saying that the area is equal to 64. So we have 64 is equal to the half times the base, which is 8. Then we times the height, which is the square root r to the power 4, 32r squared plus 256. And then what we can do is to put the 2 here, and then we divide by 6, and we divide by 8. So this is 8 times 2, which gives you 16. So I have 16 is equal to the square root of r to the power 4 minus 32r squared plus 256. This looks like horrible, but actually we just want to ignore this square root, which is square both sides. Then we can have 256 is equal to r to the power 4, 32r squared plus 256. This 256 is being eliminated. Then we have r squared as our common factor. So we have r squared times r squared minus 32 is equal to 0. So that's the r is equal to 0, or square root 32, or the -32. So actually, r is the value, if the x coordinate of this r. So which means I want to have 3 values of x coordinate of the r point. So the claim is wrong because they said that there are 4 different points, but actually we only have 3 different points. So that's for question 10. So move to question 8. We have the f of x is equal to big F plus 12, where they say that the big F is consist of 2 parts, and one part is varying as x squared, and other part is varying as x. And we have these 2 conditions. So first of all, we can say that the big F is equal to k1 times x squared, and the second part is directly proportional to x, so k2 plus x. And please bear in mind that the small f of x is combine the big F together with the 12. So we have the small f of x is equal to k1 x squared plus k2x plus the 12. So now we can apply our condition f of 2 is equal to 4. Then we substitute the value of 2 be there. Then we have 4 is equal to 4k1 plus 2k2 plus 12. And the second equation going to be substitute the value of f1, and the f of x is equal to 22. So we have 22 is equal to k1 times -1 squared, give you +1. And then we minus the k2, we plus the 12. So I think we need to do some simplification on the first line, because there are 4, 4, 2, 12. They are both even numbers, so we can take out our common factor. We have 2 is equal to 2k1 plus k2 plus 6. Or actually, we can put our 6 to the left-hand side as well. Then we have this is equal to -4 equal to 2k1 plus k2. And for the second equation, we can put our 12 on the left-hand side as well. We have 10 is equal to k1 minus k2. So this is our first equation, this is our second one. Then we can, by using the first equation plus the second equation, to get 10 minus 6, and 10 minus 4 give you 6, and then 2k1 plus k1 give you 3k1, and the k2 is eliminated, so we have the k1 is equal to 2. Then we can substitute the k1 equal to 2 into our second equation. Then what we can have is 10 is equal to k1 give you 2, and k2, that's something we need to find, so that k2 is equal to 2 minus 10 give you negative 8. So now we have the value of k2 and the value of k1. Substitute back in our first equation, so that's the f of x is equal to k1 give you 2x squared, and then minus the k2, which is minus 8x, then plus 12. So that's the relationship between the f of x and the x. So we have find out, for question A, we have find out the fx. And for question B, there's a figure shows that the graph of y equal to f of x. So this is our figure. And Q is a variable point on the graph in the first quadrant. So Q can be actually here, any points on the first quadrant. And PR are the feet of perpendiculars from Q to the x-axis. So this part is going to be perpendicular to the xy axis. So let A0 be the coordinate of P. So we have the P value is A0. And express the perimeter of the rectangle OPQR. So please bear in mind the perimeter is just this full length, isn't it? So we can just draw it. So for question B, we have this one is our OPQR, and the P is A0, and we have B. So this A means that the x coordinate, so basically from O to P, so this value is going to be A. And this one, the RQ, as this is a rectangle, so RQ is equal to OP, so RQ is basically A as well. So how can we find out the value of QP? So actually Q is on the f of x, isn't it? It's on the f of x. So the Q value got the x coordinates is A as well. So that's its y coordinate is going to be f of A, isn't it? So f of A is actually just substituting the A into this formula. So now we can say that the Q value is going to be A. The y value is going to be f of A. So that's the length here is going to be 2a squared minus 8a plus 12. Similar for OR, they are the same, isn't it? So that the perimeter is equal to 2a squared minus 8a plus 12 plus our a. Then we times the 2. Then we simplify it to get 2a squared, and then we minus 7a plus 12, the whole thing times a again, times 2. So that's our perimeter for the rectangle OPQR. And suppose that Q is located at a position such that the perimeter is 12, and someone claims that the area must be 8. This is correct. So we can calculate it. Because we have the perimeter is equal to 12, so we can say 2a squared minus 7a plus 12 times 2 is equal to 12. Then we divided the 2 to the right hand side to get 2a squared minus 7a plus 12 is equal to 6. Then we put the 6 back to the left hand side, we have plus 6 equal to 0. Then using the formula 0, 1, we have 2 as the A, negative 7 as the B, 6 as the C. We can say that A is actually equal to 2 or 1.5. So if we have the 2 as the A, so which means that we have the f of A, the y value is equal to 2 times 2 squared minus 8 times 2 plus 12. Then this will give you 2 times 2 squared, then minus 2 times 8 plus 12. This one will give you 4. But we still have a value of 1.5, so f of 1.5 is equal to 2 times 1.5 squared minus 8 times 1.5 plus 12. This is equal to 4.5. So the area is either equal to 2 times 4 equal to 8, which is correct, or 1.5 times 4.5 is definitely not equal to 8. So the claim is wrong because they said must be 8, but we actually have another combination, which is 1.5 times 4.5. So the claim is wrong.